The technology platform was originally developed at the Institute of Biotechnology of the ETH Zurich for the purpose of the rapid screening of their collection of 2,000 bacterial strains for the presence of certain enzyme activities. Subsequently, a ready-to-use system was made commercially available by Kuhner and EnzyScreen. The key element of the system is the Crioreplicator, which has 96 stainless steel pins in the same format as the 96 well microtiter plate. The pins can move individually up and down in an aluminum frame under the back pressure of light stainless steel springs. The Crioreplicator is patent protected. The replicator press is a guiding system for the replicator and enables an accurate vertical movement. The press has a counterweight at the back that allows the replicator to hold its position at any point. The handle can be fitted at either side of the press, allowing the press to be used both by left and right-handed people. The replicator press has place for 2 additional cryoreplicators. It is sensible to work with more than one replicator, since after each sampling, the replicator has to be sterilized by placing it onto a hot plate for 5 minutes. The subsequent cooling down to room temperature requires 12 minutes. The main purpose of the cryoreplicator is the simultaneous sampling of 96 frozen glycerol stocks stored at -80 degrees Celsius without thawing the remaining frozen cultures. The replicator is pressed onto the frozen master plate for 3 seconds. During this contact period, due to heat transfer from the pins to the frozen surfaces, 0.3 microliter from each frozen culture melts and forms a thin film on the end of the pins. Since the remaining cells in the master plate stay frozen, there is no viability loss, and the same master plate can be used for years and hundreds of samplings. In order to generate living cultures, the sampled cells are preferably transferred to an agar-based medium. The resulting array of colonies can then be used for the inoculation of liquid cultures in a deep well plate. To allow the well-aerated growth of liquid cultures in deep well plates, a sandwich plate cover is used. A soft silicone layer avoids spilling of cells from well to well during orbital shaking. The silicone plate is pierced with 96 holes to allow the exchange of headspace air. A cotton wool layer prevents airborne contaminants to enter the wells. To inoculate the wells, an array of colonies grown in a large petri dish may be used, or as in this video, colonies grown on agar dispensed in a regular microtiter plate. The plate is positioned under the replicator, and the replicator is pressed onto the cultures. For most types of strains, a significant part of the colonies will stick to the pins. The deep well microtiter plate filled with a liquid growth medium is placed under the replicator, and the 96 wells are inoculated by pressing down the replicator and moving the plate laterally while moving the replicator up and down. Subsequently, the sandwich cover is put on. The plate and lid are put in a special clamp that is fitted on an orbital shaker. The cover clamp secures that the deep well plate and its sandwich cover are clamped together tightly and can be shaken in a high speed and a large shaking amplitude in the absence of well-to-well contamination. Each well functions now as a mini-reactor with identical properties. After an appropriate number of days, the cells and/or supernatant can be harvested. The system is suitable for heterogeneous collections of wild-type microbial strains, as well as for clone or mutant libraries. The system has been extensively tested for bacteria, streptomycetes, and yeasts. A well-validated application area is the high-throughput screening for new enzyme activities or secondary metabolites. Another important application area is the screening and distribution of clone and mutant libraries in E. coli or yeasts. The system is also valuable for the screening for high-activity mutants, for example, generated by directed evolution. Since growth conditions in different wells are exactly identical, the occurrence of false positives is minimized. This allows mutants with only slightly improved activities to be more readily detected. Comparative studies of large collections of clinical isolates with respect to, for example, antibiotic resistance is another application area.